phosphatase isomerase actually has 13 copies of lysine, and so no matter how good of a chemist you are, I would argue it is impossible to modify this lysine here and not have any overmodification here, 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 and at the other positions on the proteins. Antibodies have over 50 lysines, albumins have over 60 lysines. It's generally hopeless to get pinpoint selectivity. Instead what you'll get is materials where you have different levels of modifications in all different places. So really, if you've ever modified a protein before, many of you probably have, the most likely chemistry you used for site-selective modification is cysteine residues. This is the sulfur-containing side chain shown here, and these can be modified quite selectively with these types of reagents. I'll show the reaction in a minute, but these are called maleiamides. That is probably the oldest known specific reaction to modify a position on a protein. Now, the reason that works so well partly has to do with the special reactive properties of the cysteine, but more important than that, cysteine is the second rarest amino acid in proteins. And so it's not very abundant. And so in many cases, using the tricks of molecular biology, you can delete cysteines you don't want to modify and introduce new cysteines where you do want to modify. So that's the mainstay of studies that involve site-selective protein modification. Now, if I were to put sort of where the frontier of the field is, these are just some of the points that I thought I would mention on this. Despite the power of cysteine chemistry, it still remains true that for many proteins, it's very hard to put one copy of a functional group in one single position. That still remains a very challenging goal in the field. And what gets even more difficult is this second point, to modify proteins in two or more distinct places with different functionalities. If I could go back for just a moment, all of these applications we have in mind involve multiple modifications in different places. Maybe we could use cysteine for one, but we need a different chemistry available for the second one. Or as Jen mentioned, you want to maybe have several different bioorthogonal things that could work in a living cell, for example.